Hello and welcome back to another episode of Cerebral Snacks. My name is Niam.
My name is Adi. Today we're going to be talking about density.
So, what is density?
Density is how compact an object is. Let's take this ball for example. You find density by knowing its mass or how much stuff is in it, and its volume or how much space it takes up. This ball takes up that much space, how much ever space is in the ball, and it doesn't weigh too much, it doesn't have too much mass, so it has a relatively low density. You find density by dividing mass divided by volume. So we take the mass of the ball and divide by its volume. For our first experiment, we're going to have to clean up a bit, so let's get ready in 3, 2, 1. Okay, we're set. On the left here, we have a bocce ball, and on the right, we have a ball full of air. One of these is going to float, and one of these is going to sink. Now, we'll talk about why in a second. Let's drop them in 3, 2, 1. If you look at that, the bocce ball sinks to the bottom, and the green ball filled with air floats to the top, and pretty quickly at that. So, why does this happen? Now, if we look at the two balls, they have about the same size. In fact, their volumes are basically equal. They both have a volume of about 1.1 fluid ounces, or 33.5 centimeters cubed. But the masses are starkly different. The mass of the bocce Polino ball is 2.1 ounces, or about 60 grams. The mass of the ball of air is about 0.001 ounces, or 0.04 grams. Now, as you can tell, because the bocce Polino ball is extremely heavy, but has the same volume as a ball of air, it's going to be more dense. In fact, the density of the bocce Polino ball is 1.8 grams per centimeter cubed. The density of the ball of air is 0.001 grams per centimeter cubed. Now, the density of water is 1 gram per centimeter cubed, and the bocce ball at 1.8 is much more dense, and the air ball at 0.001 is way low. So that's why the air ball floats and the bocce ball sinks. So now let's move on to our second experiment here.
Over here, we have some corn syrup, on top of that, water, and then on top of that, vegetable oil, and then on top of that, some isopropyl alcohol.
Now, they're separated by density. The reason why the isopropyl alcohol is floating on top is because it's the least dense. The next least dense is vegetable oil, then water, then corn syrup, which is very thick, very viscous, and very dense. So, because each of these is a different density, we can see if each of these four balls will float on separate liquids. So, let's give it a test.
So first, we're going to take our hematite ball. We're going to drop it in at the top.
It sunk all the way to the bottom. Next, let's try the silicone ball that I made. As we can see, the silicone ball is more dense than the water, so it's at the bottom of the water, but it's less dense than corn syrup. Next, let's try the foosball. Well, look at that. A foosball is less dense than vegetable oil, so it's floating above the vegetable oil, but it's still more dense than the isopropyl alcohol, so it's sitting underneath that.
Finally, we're going to take our table tennis ball. Drop it in.
And of course, because it's filled with air, it's the least dense of all the balls there, and it's even less dense than isopropyl alcohol. It's floating on top. Cool, isn't it? So over here on top, we have the ping pong ball floating on top of the isopropyl alcohol. Then, in between the isopropyl alcohol and the vegetable oil is our foosball. Then, floating on top of the corn syrup is silicone ball. At the bottom, we have a hematite ball. Now I had to use another hematite ball that's also magnetic to pull it forward because the corn syrup is extremely thick and viscous, so it's hard to see the hematite ball. But if I shine a flashlight, you should be able to see that hematite ball in there, floating at the bottom.
We hope you enjoyed this video.
To see our last one, click right there. Make sure to like and subscribe, leave a comment down below if you want us to answer a question in the future. See you next week.